Continuing with our final exam review, we pick up with question number 90, expanding a binomial. And remember, the trick here is to find your coefficients from Pascal's triangle. So we start with that triangle of ones, and then each term comes by adding the terms above it, and ones on the outside edge. So we add these terms to get threes. And then we add these terms, and we're looking for the fifth row because we're going to do a fifth power here. So you need to be able to recreate Pascal's triangle, and here finally is the row that we're looking for. We know it's the fifth row because of the 5. We start counting at row 0, row 0, row 1, row 2, row 3, row 4, and row 5. So it's clearly the fifth row because it's in the it has a 5 in that second spot. And when we expand this binomial, we'll need 6 terms. So that's another way that you can make sure you've got the right row of Pascal's triangle. The other trick is to remember the patterns, that we're going to have our first term is going to start out to the highest power with a coefficient of 1. And of course, we won't always write that. And then our next term has a coefficient of 5 from Pascal's triangle. We reduce the power on the x term, and now for the first time we get our 2 appearing to the first power. In this term, if you're curious, 2 was to the 0 power, so we didn't bother to write it. And then our next term has a coefficient of 10, and x reduces to the third power, and the 2 increases to the second power. And then we've got symmetry. Our next coefficient is 10 again. Exponent goes down on the first term and up on the second term. And then we've got a coefficient of 5, x to the first, 2 to the fourth. And our last term has a coefficient of 1, so you don't need to write that. And our x is down to the 0 term, so you don't need to write that. But our 2 is to the fifth power. So remember, another trick here to make sure you're doing this correctly is on each term, the exponent should add up to 5. So that's another easy check to make sure you didn't skip anything. And now we've got to clean up our arithmetic. Here we've got coefficients of 5 times 2 to the first. And here we've got to square the 2 to get 4 times 10. And here we've got 2 to the third is 8 times 10. And here 2 to the fourth is 16. 16 times 5 is 80. And 2 to the fifth is 32. Remember that if you had been asked to take x minus 2 to the fifth power, then the signs would have alternated. So we would have gotten the same thing we just did, but the second term, where the 2 would be to the first power, would be negative, and then positive, and then negative. So every term where the 2 was to an odd power would stay negative, and then positive, and then negative. And notice this would make sense because this represents negative 2 to the fifth power, so it would still be negative. All right, let's try one more of these. And the reason I asked you to do a cube is because this might be one that is worth remembering because we do it the most often. You could get that from Pascal's triangle as well. So it is x to the third plus 3x squared, 3 to the first power. Coefficient of 3, x to the first, 3 to the second. And then finally a coefficient of 1. X is to the 0 power, and 3 is up to the third power. And then we do our arithmetic here. We've got 9x squared. Here we do the exponent first. 9 times 3 is 27x. And then 3 to the third is another 27. So this row of Pascal's triangle might be worth remembering. You could, of course, regenerate Pascal's triangle if you think you've forgotten it. Okay, now we want to switch gears and make sure that instead of expanding, you remember how to factor the difference of cubes. Here you notice that this is 2 to the third power and 3 to the third power is 27. So to factor cubes, the trick is to remember we get a binomial and a trinomial. The binomial, we take the cube roots of each term. So here we've got a positive 2x. The cube root of negative 27 is negative 3. And then the trinomial, we square each of these terms. And when you square a negative 3, it will become positive 9. And the one that sometimes is tough to remember is this middle term. This middle term is the opposite of this product. The opposite of the product of these cubes. Of these cube roots. So these two have a product of negative 6x, so we change it to positive 6x. Okay, now that we factored that for question 92, now question 93 says find all the zeros. So we want to take what we just did and set it equal to 0. This second one is not a PST. We didn't double this middle term, so that trinomial is never going to be factorable. So how do we solve the second term? We'll have to use quadratic formula. The first term is linear, so we can set it to 0. 2x is equal to 3, x is equal to 3 halves, so there's a real root. And then for this factor, we have to solve it by using quadratic formula. Opposite of b plus or minus the square root of b squared is 36, minus 4 times a, which is 4, times c, which is 9, all divided by 2a. 2 times 4 is 8. Remember, if you're concerned about arithmetic, you'll be able to use the small calculators. You might recognize these. So 36 times 4 is a 144. And then we keep going to clean this up. So 36 minus 144 is the square root of negative 108. So we're going to have two imaginary values from that square root. So how do we split it up? Well, we split it up into the square root of negative 1, and then the 108, I certainly see it has a factor of 4, and then when I divide, that would give us, what, 27? And 27 has another factor of 9 in it. The only reason I wrote those that way is because I know these are perfect squares. So the 4 and the 9 are going to send a 2 and a 3 outside that square root. So I'm going to finish up over here. So we've got x equals negative 6 plus or minus 2 times 3, 6i with a square root of 3 as a leftover, all over 8. And then we've got to split those up into standard form. Remember, we split it up into the real part. Negative 6 over 8, I'm going to write as negative 3/4. And 6 over 8, here we've got 3/4 I radical 3. So our zeros, for our cubic, we get 3 zeros. One of them is real, so it would have one x-intercept if we graphed it, and 2 complex roots. And we'll pick up with the vector problems in the next video.